All sines and cosines, you guys are going to be learning how to find the sides and angles of non-right triangles. So like your do now that we did today would be a lot easier to use either the law of sines or the law of cosines because that technically was a non-right triangle. Okay? Make sure you're taking smart notes. Let's start with the sine rule. Why? Because sine rule is the more complicated one, so let's go ahead and get that one out the way. All right? So, the sine rule. It is used when you know the size of at least one angle and its opposite side, and one other measurement. Okay? That other measurement could be the length of a side or the size of an angle. Sine rule cannot be used every time. The only time that you can use it is if you have one angle, you know one angle, and the side opposite of it, and one other piece of information. So something like that would be if this was 50 degrees, this was 12, and then this was 17. I can use law of sines for this particular triangle to find the missing angles or side lengths. Okay? Another example, if this is 50 and this was 70 and then this was 3. That's probably not likely, but I could also use sine rule here. Okay? And this is sine rule. This is not like this is not SOHCAHTOA. This is not opposite over hypotenuse. This is a full rule. And what you see down here are basically the formulas to use sine rule to find a side length or an angle measure. Okay? The sine of angle A over side A. The sine of angle B over side B. Sine of angle C over side C equal. All of them equal. Or vice versa. The side lengths can be on top, the angles are on the bottom. Okay? Angles are represented with capital letters, side lengths are represented with lowercase letters. And the truth of the matter is you're only going to use 2 pieces of the sine rule when you are doing, when you're trying to find an angle or a side length. You'll never use all 3 at the same time. So you'll either use A and B, B and C, or A and C together depending on what's given to you. And do realize that those letters can also change based off of whatever letters the triangle is labeled with. Okay? Well, let's get right into it. You need to write that middle part. That middle part was not necessary. Okay? Notice I skipped over it as well. Just to write the formula now. We need that. That's the important thing. That is the important thing on the screen. So in this particular triangle, we're given angle A, side A, and side B. So the easiest piece of information to find at this point would be angle B. Because the formula says sine A over side A equals sine B over side B. We have 3 out of our 4 pieces of information. So we plug in. Sine 98 over 12 equals the sine of B over 9.4. How do I solve this? We cross multiply. 9.4 sine 98 equals 12 sine of angle B. To solve for angle B, we're going to divide both sides by 12. So I will have the sine of angle B equals that entire fraction. And whenever I'm looking for an angle, what do I use? The inverse. So this is the sine inverse of 94 point sine of 98 divided by 12, and that equals angle B. And that's exactly what I type into my calculator. Just how you see it, of course, making sure I'm in what mode? Degree. So What did you get? 50.8. Wait, what? 50.9. 50.9. Good stuff. How many degrees are in a triangle? 180. So then, of course, to find angle C, you can do 180 minus 98 minus 50.9, or the non-rounded answer, actually. And what do we get? 31.1. Those dots right there, that's how you let the grader know that you are using the non-rounded answer when you are using it to get another answer. Okay? Questions so far? We're almost done. What's the last thing we need to find? Side C. I can use law of sines again because I have angle C now, so I need to find side C. And of course, I was given angle A and side A. So I am going to use those two pieces of the formula. And normally I wouldn't write this first line. Okay, I would just go right into plugging in the information. So this will be sine of 98 over 12 again equals the sine of 31 point whatever the non-rounded answer was all over C. Because this time I'm looking for a side length, not an angle. One more time for the good time. How do I solve this? Cross multiply, so it becomes C times the sine of 98 equals 12 sine of that 31 number that you got before you rounded it. And then what's my last step? Divide by the sine of 98. So 12 sine 31 and whatever it was, all over the sine of 98, and then I'll get my answer. What'd you get? 6.26 centimeters? Yes. That's how you use sine rule. That's how you find side lengths and angle measures of non-right triangles when you're given an angle and the side across from it in one of the pieces of information. Questions? Yes?
Do we have to use sine A and then sine C, or can we use B and C?
You can use B and C instead of A and C. I'm a creature of habit. I always use what's given to me. Well, no, unfortunately, we had to actually use B2, B, and C. So, I mean, if we're wrong all the way. Like, there's no coming back from that. But, like, for law of cosines, there's a possibility that you could get the second part right, you get the first part wrong, if you use the original.
Two different formulas, like, interchangeable.
Are the two?
Like, when the sine is on top of the sine, and when the sine is on top of the sine.
Are the two different formulas interchangeable? Referencing these two down here, 1 and 2, yes, they are interchangeable. As long as you stay consistent. If the side lengths are going to go on top, they need to go on top for every fraction that you write. If the angles are going to go on top, then they need to be on top. Because once you start flipping them within the equation, then it's wrong. There's no hope at that point. Okay, try this one on your own. What you find first? Side C. Okay. Angle A. I probably found angle A first, but it's okay. Either way, we need both of them at the end of the day to answer the question. Angle A, what was it? 64. Good stuff. 180 minus 77 minus 39, 64. To find C, side C, someone volunteer. Can you set it up for me, please? Listen. Very good. When I cross multiply and divide, I will have 40.5 sine 39, all divided by the sine of 77, yes? Okay. Now, real quick, if you notice, yes, I skipped that intermediate step of showing what the equal and then doing the division part, okay? I can do that. I've been doing this for a really, really long time. But you make sure that you don't go just straight to like the final answer. Okay? At least show this line in the middle of you setting it up. Okay? Because one, that indicates you knew what method to use and you substituted incorrectly. M1, A1. Okay? Just in case for whatever reason you get the answer wrong. Okay? What'd you get, Alyssa? Proceed.
26.16.
So 26.16. So, oh, yep, because it's 2 dozen pieces. Mm-hmm. You're right. Good stuff. Did you include your units? Can someone set up side A for me?
Sine 77 over 40.5 equals sine 64 over A.
When I cross multiply and divide, what'd you get?
37.36 centimeters.
Yes, no? Yes? Wonderful. Okay. How do you feel? Okay. Good. I want to stay that way. The reason why I say that is because, oh, should I do that? Mm-hmm. Yes. Yes, we are going to do this one. Mm-hmm. It's not the reason why I said that. It's what's actually on the next slide. Okay? You got a second to write it down. Get the main information from this, okay? Or just start drawing the picture to see if you actually get it. Let's see. Okay? So, I'm sailing north. Okay? I see a lighthouse. How far away? 10 kilometers away. At a bearing of 0.32. And remember, bearings always come from the north direction, going clockwise. Okay, I travel for a little ways, and then at a certain point, when I look again, the lighthouse is on a bearing of 132 degrees. I never left that north direction. And because north is an exact straight line, how many degrees are in a straight line? 180 degrees. So even though I have created my triangle here, this angle on the inside, even though it's not labeled, I can find it by doing 180 minus 132, which is what? 48. Question? Because it said that later. So he's sailing. At one point he sees it at 32, and then later in his travels, so that meant further down the way, he saw the lighthouse again at a different bearing. So he had to pass the location of the lighthouse to see it at a different type of bearing. You are trying to figure out how far apart or the distance between those two observations. And I can use sine rule here. Question?
What's the significance of putting the 0 before the degrees?
Because true bearings are, they use 3 digits. So anytime a number is less than 100, you have to have that 0 in the front of any double digits or single digits, 2 zeros. Yes. Okay. So then what's this angle that's missing in my triangle? 100. And then again, like I said, we can use law of sines to set it up. Okay? Can I get a volunteer to set this up?
Sine of 132
Mm-hmm.
over 10.
Mm-hmm.
Wait. Sine of 48
Sine of 48
over 10
over 10
equals sine of 100 over x.
Very good. So applying the concept of a law of sines, including a little bit of bearing, when you cross multiply and divide, because again, I'm not looking for an angle, so there's no need to do any inverse or anything like that. Type that in. And I get my answer. My answer.
13.3.
13.3.
Well,
Thank you. Now with the law of sines, there is time when you won't always have one triangle. There's a possibility that you could have two triangles that have this information that it could work for, and there's a possibility that you'll have no triangle at all, and that is called the ambiguous case. Okay? Ambiguous case only applies to the sine rule. When we talk about cosine rule, there is no ambiguous case for cosine rule. It is only for sine rule. And the ambiguous case happens, or you kind of need to check for the ambiguous case when you're given two sides and a non-included angle. And that non-included angle is acute. And when the side opposite of that acute angle is shorter, is the shorter one out of the two. Now, this little table down here at the bottom, I do not expect you guys to memorize this, okay? However, some people like to have this like visual of, well, when am I not going to have a triangle? When am I going to have one triangle? When am I going to have two? That's there for you, okay? But the main thing that I always use to recognize when I need to check for the ambiguous case of potentially two triangles is, again, when I have a side-side angle situation, two sides and a non-included angle, and when the side opposite of that acute angle is smaller. What does that look like? This is 5, this is 13, and this is 61. Okay? Two sides and a non-included angle, so the angle's not in between. And then the side across from the acute angle is shorter. Now, if this angle was obtuse, you have just the one triangle, okay? Or you could have no triangle, but you will never have two. It's really the two one that throws students off. Here's an example. Just get down the information, okay? Just get down the information of the triangle, A, B, and C. Or A, and C. Now, this is a side-side angle situation where you're given two sides and a non-included acute angle. The acute angle is across from the smaller of the two given sides. And right off the bat, you should think, okay, I definitely need to make sure I check for this ambiguous case here, okay? I am just going to draw one triangle for now, so that way I can have the visual. 40 degrees for angle A, 14 for side A, and 20 for side C. You still start off the same way you would if this was any other normal sine rule problem. What should I find first? C is the easiest thing to find first, okay? Let's set it up. Sine of 40 degrees over 14 equals the sine of angle C over 20. Cross multiply. Divide, and then I'm going to have to do what? Take the inverse. So C is going to be equal to the sine inverse of 20 sine 40 all over 14. Now, if this is going to be a situation where there is no triangle, if there was going to be a situation where there is no triangle, when you type this in, you're going to get an error message. Okay? So right off bat, from you finding the first piece of information, if this is a no triangle situation, you're going to get an error message and you can't go forward from there. There is no triangle that is possible to have an angle of 40 degrees, the side across from to be 14, and then another non-included side to be 20. When you type it in, what do you get?
66.
So we do get a value. So then that means that there's at least one triangle here.
What would you write if there is no triangle? Just no triangle?
No triangle. Mm-hmm.
And that would be the end of the problem.
And then that would be the end of the problem. You said 66?
66.7.
66.7. That's right. Yep, and we're going to 1 DP. Perfect. Okay, so we know we have at least one triangle, and angle C is 66.7 in this triangle. That's the first thing. Find that angle. And it'll always be an angle when you're doing the ambiguous case. It'll always be an angle that you find first. Again, if this is an error message, that means there's no triangle and you're done with the problem. But if you get an angle, you need to check for the ambiguous case. Or the ambiguous case of having two triangles. At this point, this is where you do it. There is a possibility where there is another triangle that has an angle A of 40 degrees, a side A of 14 degrees, and a side C of, not 14 degrees, 14, whatever, and a side C of 20 centimeters. However, angle C is going to be the supplementary angle to the angle C that you found over here. So after you find your first angle, you want to see what its supplementary angle would be. So you do 180 minus the 66.7 number that's still in your calculator. Question?
Why are we finding the supplementary angle?
Because remember from the demonstration, that first angle that's on the inside, that is the supplementary angle to the one that's on the outside.
And this is the one that changes.
Mm-hmm.
Okay.
Yeah, this will be the angle that changes. This will be that bottom part of that demonstration that I did. Okay, so I'm going to do that real quick. 180 minus that number?
113.3.
113.3. So, you need to make sure you do this step here. Because if this is indeed a two triangle situation, then when you add these two up together and subtract it from 180, there should be a positive angle here. Can you add up those two sides, angle A2 and angle C2, and subtract it from 180 and tell me what it is? $26.7. So then this is one of those situations where you're going to have two triangles. This is that demonstration that I was showing you. Which means that you don't have just one set of answers here. You have a set of answers for your orange triangle where angle C is 66.7, and you'll have a set of solutions where angle C is 113.3. Yes? Once we found that angle C, you add the two angles and subtract it from 180. So remember, there's 180 degrees in the triangle, always. If there was no second triangle, that angle would have been a negative. So then there will only be the one original triangle.
So for every problem that we solve like this, we have to...
For every problem where it's a side-side angle situation, the angle is acute, and the side across from that acute angle is smaller. You need to check for this. Yes. That is the only stipulation. Okay? That is the only stipulation. So now since we have two triangles, we're going to basically need to find angle B and side B for the orange triangle, and the last thing over here will be side B for the purple triangle. Okay? And we still use law of sines and cosines from here. So we'll have basically 3 answers for each. 6 total. Yes?
Would side A squared, B squared, would 20 change?
No, the original information, the 40 degrees, the 14 and 20 centimeters, those stayed the same. So those were like the 2 linears at the top and the angle that was at camera thing. Those are the 3 that don't change. Okay? So, can you guys find angle B and side B on the orange triangle for me, please? And then side B on the purple triangle. Can you guys do that? So you guys are finding angle B and then side B on the orange triangle using law of sines. And then side B on the purple triangle using law of sines. So over here for your orange triangle, okay? Over here for your orange triangle, you need to find angle B. Of course, it's 180 degrees in a triangle, right? So that's 180 minus 66.7 minus 40. What did you get? 73.3? So 73.3 was angle B for the orange triangle. Now you need to find side B, again, using law of sines. The sine of 40 over 14 equals the sine of that 73.3 number all over side B. When you cross multiply and divide, that's 14 sine of 73.3 divided by the sine of 40. And your answer for B should have been what? 20 point what? Centimeters. Questions? Up here for the purple one, again, you're still using sine rule. Sine of 40 over 14 equals the sine of 26.7 over B. Cross multiply and divide. What was your final answer? 9.8 centimeters. Questions? All right, let's talk about cosine rule. It's short, very simple. Okay? Probably won't get to all the examples, but that's okay. As long as you get your practice, you'll be fine for the homework. Those are the formulas for the cosine rule. To be honest, in your reference booklet, they only give you this first one right here. But the thing is, I put the other ones down, so then that way you can see that it really, the side lengths are interchangeable. Okay, the side lengths are interchangeable. The one down here at the bottom, the only one that's filled in is the one that's given to you in your reference booklet. The long equations are used when you're looking for a side length. The ones on the bottom are when you're looking for an angle. The cosine rule or law of cosines is used when you have all three sides in a triangle, when you're given all three sides, or you have two sides and an included angle. So side, angle, side, or side, side, side. Only those two is when you use cosine rule. Okay? Your do now, your problem of the day, this would have been a cosine rule problem because you had two sides and the angles in between the two sides that you were given. Bless you. Like I said, the top equation is the one that's given to you in your reference booklet, where the lowercase letters represent your sides and the capital letters represent your angles. The main thing, because it doesn't matter which way you write it, whatever side length you're looking for, you're always given the angle opposite of it. That's how you know the setup of how you plug everything into the formula. Same thing. The ones at the bottom, you're looking for an angle. Whichever angle you're looking for, you always subtract the side that's opposite of it. Okay? So if I wanted to find angle B, I would set it up as the cosine of angle B is equal to a squared plus c squared minus b squared all over 2ac. Okay? You always subtract the side that you are, the side opposite of the angle that you're trying to find. What if I wanted to find angle C? Yeah, a squared plus b squared minus c squared all over 2ab. And it does, like I said, it doesn't matter for the switch, okay? Because it's addition. So interchange. All right? We're going to find A, side A, and the missing angles. Okay? That's 13.2, angle 80, and 8.9. To find lowercase a, would I use the long formula or the fraction formula? I will use the long. Remember, the long ones are used when you are trying to find a side length. And since I am looking for a, it's going to be a squared equals b squared plus c squared minus 2bc cosine angle a. b squared plus c squared minus 2bc cosine. Don't underestimate the writing of the formula and the plugging in of the pieces. How do I actually solve for a, though? What do I have to do before I actually get my answer? I have to what? What? I have to square root both sides. So in that way I can get a all by itself. So once you type in this whole line, you can type in that entire line all in one. If you want to, you can put the square root over it and get your answer, okay? But the one thing I do not want you to do, the one thing that you cannot do, is you cannot square 8.9, add it to 13.2 squared, and then subtract it from whatever 2 times 8.9 times 13.2 is. You cannot do that. This part right here, all of that is connected, which means that you cannot subtract whatever the number is before the cosine of 80 from whatever the sum of those other two numbers are. You cannot do that. You do not get the same answer. Okay? That's why I just said just type the whole thing in. All in. Then take the square root. What do you get? You haven't done it? No. Okay. Sorry. So again, you can type that whole thing in, all underneath the square root. And did we get 14.6? Yes. Wonderful. So A is equal to 14.6. Okay? To find angle B or angle C, either one. Yes, at this point in time, we could use the sine rule. But since we are doing cosine rule and I'm trying to hit as much as I can about this in the short amount of time that I do have, I'm going to use cosine rule to do this. Okay? Which angle you want to find, B or C? B, the first one I heard. So, cosine of angle B is equal to what squared? Plus what squared? Minus what squared? So, A squared plus C squared minus B squared all over 2 AC. I forgot the 2 up here. And because I'm looking for an angle, once I figure out what that fraction is, I need to do what? To find the angle. I do the inverse. Okay? So I need to take the cosine inverse of this entire lot. Okay? So when I go on my calculator, I am going to do it all in one line. You don't have to. You can do it individually. But I'm going to do the cosine inverse of that entire fraction. My previous answer, squared, plus 13.2 squared, minus 8.9 squared, all over 2 times my answer, times 13.2. Now again, you do not have to do it this way. If you want, you can find the entire numerator, write that number down. Find the entire denominator, write that number down. Divide the two, then take the cosine inverse. You can do that. Okay? A lot of steps. Let me just do that. Huh? Sure. Did we get that? 36.9? There you go. So angle B is 36.9 degrees. And of course, angle C can be found by doing 180 minus the other two angles. And what is C? 63.4. Not that this would happen, but to prevent any types of errors, your longest side should be across from your largest angle. Your longest side should be across from your largest angle. And when we look at this, 80 is my largest angle, and 14.6 is my longest side. Okay? This is another quick way to be like, okay, did I do this right? Do my numbers make sense? Yes, they do make sense. So I miswrote. That should have been a 63.1. My mistake. Sorry, that should have been 63.1. 63.1. Thank you for the correction. I'm good now? Yep. Wonderful. All right. But that is how you can find these side lengths and angle measures of non-right triangles. Okay? You will use the law of cosines when you have all three sides. Or what other situation? Side, angle, side. If it's not those two, it's law of sines. And remember, with law of sines, there's that one stipulation when you have to check for either no triangles or two triangles. If it's a side-side angle, that angle is what? Acute. And the side across from that acute angle is smaller than the other one. So there you go.